Hello everyone and welcome back to the channel. I am Praveen Ravindran Pillai. Today we are doing something really cool. We are building the exact same application in 3 different programming languages using the Anthropic Claude API. And here is the kicker. We are going to stream the responses in real time across all 3 implementations. Whether you are a .NET developer, a Java enthusiast or a Python lover, you will see exactly how to integrate Claude into your tech stack. Let's jump right in. So here is what we are creating today. A simple but powerful CLI application that takes user input and sends it to Claude API, then streams back the response word by word. This is a practical example that shows you the core workflow you will use in production applications. The app will accept user input from the command line, send it to Claude API using your API key, stream the response in real time, and display the output as it arrives. We are building this in .NET, Java, and Python. Same logic, 3 different languages. This is perfect if you are evaluating which language to use, migrating between platform, or just curious how different ecosystems handle API integration. Before we dive in, you will need a few things. First, grab your Anthropic API key from console.anthropic.com. If you don't have an account yet, sign up. It's free to get started. Second, make sure you have the runtime or SDK installed for whichever language you are following along with. For .NET, you will need the .NET SDK. For Java, grab the latest JDK. For Python, use Python version 3.8 or higher. I have linked the setup guides in the description, so check those out if you need help getting your environment ready. Let's start with Python, since it's often the most straightforward. Python's simplicity and strong ecosystem make it a great choice for working with APIs. For this demo, I created a Python project using the modern tool named UV. UV is a fast and efficient tool for managing Python projects, packages, and virtual environments. To create a Python project using UV, first install the tool on your operating system. This is straightforward and can be done via a web search. Next, create a folder and open it in a terminal window. Run the command UV init to create a new Python project in the current directory. Then execute the command UVVENV to create a Python virtual environment. This isolates project dependencies, allowing different projects to use different package versions without conflicts. Activate the virtual environment by running the appropriate command based on your operating system. For example, if you are using Mac, execute the command source space .venv/bin/activate. If you are using Windows, .venv/script/activate.bat. Finally, run UV add Anthropic to install the Anthropic SDK and add it to your project dependencies. I have already created a folder, executed these commands, and opened the project in Visual Studio Code. You will find a collection of files and folders made by UV. Now, let me create a new Python file which streams the response. Let me name the file as Claude_streamer.py. At the top of the file, let me import the Anthropic client, OS module, and the generator. From typing, import generator is used for type hints. It helps readers, IDEs, linters, and type checkers understand that a function returns a generator and what types it yields. Then, we initialize our Anthropic client. Here, we are pulling the API key from an environment variable. This is a best practice. Never hardcode secrets in your source code. Specifying the API_key while we initialize the Anthropic client is optional. If the Anthropic_API_key environment variable is configured, the Anthropic SDK will automatically detect and use it. I thought it would be helpful to include it so users can see what's happening behind the scenes. Now, let me create a streaming function, which is the heart of our application. This Python code defines a generator function that interacts with Anthropic's API to stream a response from a Claude model in real time. Instead of waiting for the AI to generate the entire response before returning it, this code fetches and returns the text chunk by chunk as it is being written. Now, let me explain this code in detail. The streaming function can be divided into 4 sections: function definition and type hinting, the API connection, API parameters, and the streaming loop. Now coming to the function definition and type hinting. The function takes a single argument, which is the prompt or question the user is asking, expected to be a string. The type hint indicates that the function returns a generator. Specifically, it yields strings, receives nothing when resumed, and returns nothing when it finishes. Under the API connection section, the client.messages.stream calls the Anthropic Python SDK to initiate a streaming request. Using a with statement ensures that the network connection is cleanly opened and safely closed automatically once the stream is finished or if an error occurs. Under the API parameters, the model specifies which version of the Claude model to use. Here we are using the Claude Sonnet model. The max underscore tokens equal to 1024 sets a limit on the length of the AI's response. It will stop generating after 1024 tokens, which is roughly 750 words. The messages parameter packages the user underscore input into the specific dictionary format that the API expects, labeling the source as the user. Now coming to the streaming loop, the stream.text underscore stream is a property provided by the Anthropic SDK that automatically extracts just the text content from the incoming stream of servers and events. The yield text is the magic word that makes this function a generator. Instead of using return, yield spits out the current chunk of text to whatever called the function, pauses the function state, and waits for the next chunk to arrive. Why use this pattern? When you use AI applications like ChatGPT or Claude's web interface, the text appears to type itself out on the screen. This streaming generator is exactly how that is achieved on the backend. It drastically reduces perceived latency because the user starts reading the first few words immediately rather than waiting 10 to 15 seconds for the entire response to finish processing. Now let's build the main function in the main.py file. Let me paste the code here. This Python code acts as the main control loop for a command line chat application. It continuously asks the user for input, sends that input to the streaming function that we already created, and prints the AI's response to the console in real time. Now let me explain this code in detail. The main function can be divided into 5 sections: setup and infinite loop, gathering and validating input, preparing for the AI's response, the streaming output, and error handling. The first 2 sections are pretty straightforward. Now, coming to the third section, preparing for the AI's response. In the print statement, it prints Claude to let the user know the AI is speaking. The end is equal to empty string. By default, Python's print function adds a hidden new line character at the end, moving the cursor to the next line. This overrides that behavior, keeping the cursor on the exact same line. Now, flush is equal to true. Normally, Python buffers console output, waiting to print text until it has a full line. Flush is equal to true forces the terminal to display Claude immediately without a new line. Now coming to the streaming output, the try opens an error handling block just in case the API goes down or the internet disconnects. The for chungin statement is where it calls the generator function. As the generator yields each new piece of text, this loop processes it. The print statement, just like the prefix above, this forces every single incoming chunk of text to print directly to the console immediately, right next to the previous chunk. This is the core trick that creates the visual typewriter effect on the screen. Finally, the error handling part. If anything goes wrong inside the try block, specifically related to Anthropic API, the program catches the error. Instead of crashing the entire script with a messy traceback, it gracefully prints API error followed by the specific issue, and the while loop continues, allowing the user to try again. To run this application, set your API key in your environment. For Mac OS and Linux, open the terminal window, execute the command export Anthropic _API key equal to your API key. For Windows, open your Windows PowerShell and execute the command $env Anthropic _API key is equal to your API key. Now let's go and run this application. Open the terminal window and run the command uv run main.py. And you will see a prompt. Type a question like, tell a joke about Python language under 100 words. And watch Claude's response stream in real time. Wow, How cool is that? That's the Python version. What I love about this implementation is how clean and readable it is. Python's dynamic typing and the Anthropic SDK's thoughtful design make it straightforward to implement streaming. One more thing, you can enhance this further with features like multi-turn conversations, custom system prompts, or response post-processing. But this core pattern is what you will see across all your Python projects with Claude. Now, let's build the same application in Java. Java brings structure and type safety, which is great for larger projects. First, we will create a Maven project. If you are using Gradle, the process is similar. Create a new project and update your pom.xml file to include the Anthropic SDK. We are using Maven to manage dependencies. The Anthropic SDK is the key library. I have already created this Maven project with the Anthropic SDK dependency and it is open in IntelliJ IDE. In this project, I have created a class named Claude Streamer to interact with Anthropic's Claude API. If you are looking to integrate Claude into your Java applications, specifically for streaming responses, getting the foundational client setup correctly is crucial. Let's walk through the code. Right at the top, I have defined a couple of static constants to keep things organized. First, we have our model string. I have set it to Claude-sonnet-4-6 here, but always double check the Anthropic documentation for the exact current model string to ensure the API accepts your request. Below that, we set max_tokens to 1024, which acts as a safety limit on how long the AI's response can be. Next up is the constructor, and this is where we handle authentication. As a standard best practice, we never want to hardcode API keys. Instead, I am grabbing the key directly from the system environment variables using the system.getEnv function. To make sure this class does not fail silently later on, I added a quick null check. If the environment variable is not set, it immediately throws an illegal argument exception. This is great for debugging because it tells you exactly what went wrong the second you try to run the application without your keys configured. Finally, assuming our key is present, we initialize the Anthropic client. Because we are using the SDK, we can simply call Anthropic OK-HTTP client.fromEnv function. This is incredibly convenient because the SDK actually looks for that exact environment variable under the hood to build the client for us. Our manual check right above it ensures we get a clean, human-readable error before the SDK even tries to boot up. Now let me add the streaming function, which is the heart of our application. This is more verbose than Python, which is typical for Java. Let me break it down. The streaming function is divided into three sections: build the request parameters, initiating the streaming request, and processing the stream. Now coming to the first section, it uses a builder pattern to construct the API request. This is a standard Java approach for creating objects that require multiple configuration steps. The .model function specifies which AI model to use. The .maxTokens function sets a hard limit on how long the AI's response can be. The .addUserMessage takes the text the user inputted and adds it to the request as the prompt. And the .build function finalizes the construction, creating the immutable params object that will be sent to the server. Now coming to the initiating the streaming request section, the try block is a try with resources statement. Because streaming a response open an active network connection, this ensures that the stream response is automatically and safely closed once the block of code finishes executing, preventing memory or network leaks. Instead of waiting for the AI to generate the entire response before returning anything, the create streaming method opens a connection that allows the server to send the response back in small chunks as they are generated. Processing the stream. This block uses the Java Streams API to process the incoming chunks of data in real time. The .stream method converts the incoming network response into a reactive Java stream of events. LLM streams send many types of events like message start, message stop, token usage stats, and so on. The .filter function filters out everything except the actual text generation updates. The .map function casts or converts the generic event object into a specific content block delta object so you can access the text inside it. The .flatMap function unpacks the text wrapper object from the delta. It essentially says, get the actual text fragment from this event. And the .forEach function takes each tiny chunk of text and prints it to the console using system.out.print. This is what creates the typewriter effect you see when using ChatGPT or Claude, where the text appears letter by letter. Now, let's focus on the main method. In the main method, I have created a Claude Streamer instance. Scanner is used to read the user input. Scanner is Java's standard way to handle console input. The loop is similar to Python. Keep running until quit is entered. We validate input and call the streaming method. Now, before running your application, make sure that you have set the environment variable Anthropic_API_key with your API key. Now, let me go and run this application. Now, let me ask a question like, tell a joke about Java in 100 words. And here you can see that a Java joke is getting streamed as a response. Okay, that's the Java version. The Java implementation shows us a few important patterns. The builder pattern for configuration makes code readable and type safe. Event-based streaming is more complex than Python's iterator pattern, but it is powerful once you understand it. Java's strong typing helps catch errors at compile time. Finally, let's build this in .NET. C# is elegant and the Anthropic SDK for .NET is fantastic. For that, we need to create a .NET Console project, add the official Anthropic NuGet package and open the project in an IDE. I have already created this .NET Console project and opened in JetBrains Rider. In this project, I have created a Claude Streamer class. Right at the top, we lock in our core configuration using private read-only fields. We specify our model here, targeting a version of Claude Sonnet, and set a hard limit of 1024 for max tokens. This keeps our AI's responses concise and helps control API costs. Finally, we declare the Anthropic client, which will be the engine doing all the heavy lifting. Next up is the constructor, and this is where we handle security. Notice how we are not pasting our API key directly into the code. Hardcoding API keys is a massive security risk. Instead, we securely pull it from the system's environment variables. If the system can't find that key, the application immediately throws an invalid operation exception. This is called a fail-fast approach. It stops the program dead in its tracks before it can make unauthorized API calls, saving you from confusing network errors later. Once the code verifies that the API key actually exists, we initialize our Anthropic client. We pass that secure key into a new client options object which gets handled directly to the client. And just like that, this class is securely authenticated with Anthropic and fully primed to start streaming AI responses. Now let me add the streaming function, which is the heart of this application. Let me paste the code here. And I have created a function named stream Claude response. The streaming function is divided into 5 sections: the setup, configuring the request payload, opening the stream, listening for data, and filtering and rendering the text. Now let me explain each section in detail. Now coming to the setup section, the public async task declares the method as asynchronous. It means this method will perform network operations that take time, but it won't freeze your application while it waits. The method takes one argument, the prompt you want to send to Claude. The console.write Claude, this simply prints the label to the terminal. It uses write instead of write line so that the AI's response prints on the exact same line right after the colon. Configuring the request payload section builds the exact configuration object that the Anthropic API expects. Model and max tokens define which AI model to use and the absolute maximum length of the response. The messages is an array representing the conversation history. Since this is a simple prompt, we are sending exactly one message where the role is user and the content is the text you pass into the method. Opening the stream. This is the bridge between your code and the API. Instead of asking the API for a standard response, Create Streaming opens a continuous connection. It prepares your application to catch the text piece by piece as Claude types it out. Listening for data. The await for each is a special type of loop used for asynchronous streams. It tells your program, hey, wait here until a new piece of data arrives over the network. Execute the code inside the loop and then wait for the next piece. And finally, filtering and rendering the text. This is the most important section. APIs send a lot of hidden metadata in a stream like start signal, stop reasons, and token usage. This section filters out that noise to find the actual words. The stream event.tryPick content block delta checks if the current event actually contains a chunk of message. If it doesn't, continue, skips to the next event in the stream. The switch delta.delta use pattern matching to inspect the delta. If the delta contains text, it extracts it into text delta. And finally, the console.write prints the tiny chunk of text directly to the console. This looping process is what creates the smooth real-time typewriter effect. Now, let's work on the main method. The main function, that is the entry point of the program, is marked async because it needs to wait for network calls to the AI without freezing the application. Then, it prints a simple welcome message and instructions on how to exit. Everything is wrapped in a try block, so the program can gracefully handle any errors that pop up during the setup or execution. The var streamer is equal to new Claude streamer creates an instance of the class that actually talks to the AI. The while true creates an infinite loop keeping the console window open and waiting for user input until they explicitly decide to leave. It prints a greater than symbol as a prompt and reads the user's text. If the user types quit, it prints goodbye and uses break to snap out of the loop and end the program. If the user just presses enter without typing anything, it warns them and uses continue to jump back to the start of the loop instead of sending an empty prompt to the AI. Finally, the await streamer.streamCloud response function. It sends the valid question to the Claude. The await keyword ensures the program waits for the AI to finish streaming its response to the console before moving on to the next line. If anything goes wrong, the code catches specific errors, prints a helpful message in red, and forcefully closes the app with environment.exit. The invalid operation exception catches configuration errors like the Anthropic API key being missing from the previous code. The HTTP request exception catches network issues like losing your internet connection or the Anthropic API being down. And an exception, a generic exception, catch all for any other unexpected bugs. Now, before running our application, make sure that the environment variable Anthropic API key is set with the valid API key. Now, let me go and run this application. The application is running, and let me add a prompt like tell me a joke about C# in 100 words. So let me click enter, and you can see the streaming response getting printed in the console. So we just built the exact same thing 3 times. Same prompt, same streaming behavior, same end result in .NET, Java, and Python. And honestly, the biggest takeaway is not which one is better. It is that the core pattern is identical everywhere. Authenticate with your API key, open a streaming connection, and process the chunks as they arrive. Once you understand that pattern in one language, you basically understand it in all 3. The syntax changes, the concept does not. What really differed between them wasn't speed or quality, it was developer experience. In Python, the generator pattern made streaming feel almost invisible, just a for loop and you are done. In Java, the event-based model gave us more explicit control, which is great if you are integrating this into a larger type-safe enterprise system. In .NET, await for each struck a nice balance, modern, async first, and very readable. None of these are wrong. They are just different philosophies for solving the same problem. Here is the thing. The language you should pick has almost nothing to do with which one is faster for this use case. The Claude API itself is the bottleneck, not your runtime. What actually matters is, what does your team already use? What's your existing code base built in? Are you adding AI features to a current .NET Enterprise app, a Java backend, or a Python data pipeline? The right answer is whatever fits the system you are already building. That's it. So instead of asking which language is best, drop a comment telling me which one you are going to use this in and what you are building. I would genuinely love to see what people create with this. If you find this video helpful, please like, share, and subscribe to my YouTube channel and stay tuned for the next updates. Thank you.